So I'd like to try these three problems, but before we get there, a quick FYI. So let's say that you were given 2 points, P and Q, and the goal was to find this vector and this vector. This notation up there, that denotes a vector. So let's focus on finding PQ, and then we can find QP. So what's one way of doing this? You can make a graph. So these are points because there are parentheses where this is x comma y. Where exactly would point P be? It'd be at -6, 8. So roughly speaking, it'd be like right there. Yes, that'd be point P, and it's at -6, 8. What about point Q? It's at 5, -1. Let's say that's like right here. That's point Q, and the coordinates are 5, -1. What we want is PQ. Let's focus on that one first. Now, the notation for a vector is not parentheses. It's actually these little, they look like alligator mouths, right? Little thingies like that, and put a comma. Now, let me tell you this. This is called a component. This is a component, and this is a component. Overall, this is called component form. Now, this component, it's either left or right. And this one here, it's either up or down. Now, what exactly is a vector? A vector is an object, and it takes you from one point to the next, like this. I kind of crooked, but it's okay. So this here is a vector. It's a vehicle, and it transports you from one location to the other. But the question is, instead of going straight, what if we took the streets and we did that? So the question is, how much did I go this way and how much did I go that way? Well, if I had graph paper, I could count the boxes, but I don't have graph paper. So what's a different way of doing this? Well, you're going from here to here, right? But how much is it sideways? I'll tell you. It's going to be 11. How did I know? Because we went from -6 to 5. To go from here to here, are you going bigger or smaller to go from here to here? You get bigger because you went from negative to positive. But how much ground did you cover? You went from -6 to 5. That's 11. You know how you can get 11? You can go 5, subtract that number, and the double negative becomes positive. So 5 plus 6 is 11. That tells me that I went 11 spaces to the right. Now, obviously, you go down, but how many boxes? I don't know because I can't count because it's not graph paper. But it's all right because you just look at the numbers. You're going from 8 down to -1. So you went down. How many spaces? Well, it would be 9, right? But negative, and I'll tell you why. You can always go the last number minus that last number, and that's how you get -9. And it should be negative because you went down. So the point is, this number is left, right. And if you're going to the right, it's positive. If you're going to the left, it's negative. This number is up, down. If it's positive, if it's positive, that means you went up. If it's negative, that means you went down. So do you have to make a picture? No, but it helps. But you don't have to. And for example, let's try QP before we go on to the main problems. Let me try it down here. QP, so now this time you want to begin here and you want to go all the way up to P. So this time you're going to have to move left and then you're going to have to go up. So how much do you have to move left? Well, it's 11, but since you went left, it's going to be negative. And then you went up. So it's 9, and this time it's positive because you went up. So the point is, for a vector like that, if it's PQ, the fast way is go the numbers from Q minus the numbers from P. So let's say on a test, you see something like that. Yes, you are moving from A to B. You are. But to find the numbers, you go the numbers from B minus the numbers from A. So with that in mind, let's try this problem right here. We're given 2 points and we want this. I am not going to make a graph because you don't have to make a graph. First things first, let's find vector RT. So I do the usual setup with the little alligator mouths. Now I need this here. How do I know what goes here? Well, if it's RT, then I go the T's minus the R's. So I have to go -4 minus 3, and that's -7, which you put there. And in here, I should go T minus R, right? T minus R. I should go -5 minus -7. And the double negative becomes positive, so it's 2. And that tells me that if I made a picture to go from R to T, I'd have to move 7 spaces left and 2 spaces up. And I believe that because R should be like down here, and then T is gonna be like over there. And I wanna go from R to T. I wanna go like that. So I have to go left, and then I have to go up. And that makes sense because this is negative, so it's left, and that's positive, so it's up. And now, but we're not done, right? That's just RT. This is square root 7 times, so what's RT? That there. And then you remember the distributive property? You just distribute if you want. So this would be negative 7 square root 7. And it would be 2 square root 7. So again, I just made up this problem, but it mimics yours. And that would be the final result. So first, find that piece the way we did. And then if there's a number on the outside, you distribute it to the pieces on the inside. And that'll be it. Let's try this one right here. So that's given here. Now notice, look, this is not a point. This is a vector. So this is already prepared. And this is also a vector. So this is not a point. These are vectors. And I want to know what this is. So let me see. Let me keep negative 4. Now instead of P, I know what P is. P is this. So I can multiply, little dot for multiplication, like that. So I have negative 4, and that's P. And then the subtraction, that's right here. And then I have 10 times. And then what's Q? Q is that there. And what can we do? How about we distribute the negative 4? So that'll be negative 20, comma, positive 28, because the double negative becomes positive. Instead of subtraction, turn this into a positive, but make the 10 negative. You see what I'm saying? And now distribute negative 10 and keep it as addition. I would recommend doing that whenever you have subtraction. Turn it into addition, but make that number negative. So now distribute negative 10. And then now we have a vector plus a vector. A vector plus a vector gives you another vector, and you add the numbers that correspond. So these ones go together and these ones go together. So if you add these, that's 70. If you add these, that's negative 102. And this is what they wanted, and that's what they get. All right, last one. We're given 4 points, and we want these 2 vectors being added together. First things first, let's focus on this piece here. What is AB? Let's see, let's decide that together. So vector AB goes from A to B. So remember, to do that, you go the pieces from B minus the pieces from A. So I'm looking at these ones here. So let me go 2 minus negative 5, should be 7. And then go negative 8 minus 7, that's negative 15. Now, what about CD? So CD, so you want to go the pieces from D minus the pieces from C. So negative 6 take away 3 is negative 9. Negative 1 take away 12 is negative 13. So now we have the vectors that are necessary to find this goal. So now let's go back to the main problem. So I have negative 3 is there, times. Now what's AB? We found it. It's that right there. Addition. And how much is CD? It's that vector right there. And we can distribute the negative 3. And then we can finish this problem by adding the vectors component-wise. These are the components that match. And if you add them, that's negative 30. And if you add those, it should be 32, it looks like. Pardon the sloppy writing, but there it is. So first build the necessary vectors off to the side as some scratch work, and then do the main operations. So let me know if you have any more questions, and I'll gladly help.